Okay, good afternoon, everybody. I'm Dennis Lewis, and I'd like to thank you for the opportunity to talk to you a little bit this afternoon about our experiences at IDT using Lynx. So I'll give you a little bit of background. First of all, IDT was founded in 1980 and currently employs about 2,000 people worldwide with the headquarters here in San Jose. We like to think of ourselves as the sort of analog and digital company, basically providing mixed signal, sort of application-specific solutions in the communications, computing, and consumer marketplaces. The communications division that I work in particularly is number one in rapid I/O switching solutions, and we provide products that service the aerospace industry, the wireless infrastructure, telecommunications environment, and a wired communications environment. In particular, the product that we chose to utilize Lynx with and deploy within IDT is what we consider a bridging product that helps enable our rapid I/O environment. And basically what it does is it's a bridge chip that sits in between a sort of Generation 2 PCI Express environment, or chip that would produce this protocol, such as an Intel Sandy Bridge processor. And then on the right-hand side, you'd have an interface into the rapid I/O network, which would be provided by a serial rapid I/O switch, which IDT sells. Or we have IP that goes into TI's DSPs that would also give you that interface. And basically what happens is it just bridges between the two protocols and provides some basic messaging and DMA capability. So let's delve down into the details. Basically, we chose to implement Orion in TSMC's 65 nanometer process as a flip chip product. And at the end of the day, we had approximately 3 million placeable instances on the design. Now, 10, 12 million gates. It's not monstrous by today's standards, but at the end of the day, it's not a little tiny chip either. It did present several implementation challenges. We had over 300 memory instances, as you can see. These black boxes all over the place, with a maximum clock frequency at 312 megahertz. And at the end of the day, when we coupled all the extraction corners with our modes, we needed well over 50 different STA sign-off corners. So we did all that with just a 4-person implementation team. And then the team up was that one individual was responsible for constraints, synthesis, and sign-off STA. I had another physical engineer that was responsible for the top-level integration, and then another individual that was responsible for this mega block you see on the right-hand side, outlined in orange. And then myself, I took on the two blocks, the one in blue and the one in red, as well as the overall implementation management roles. So why would IDT consider utilizing Lynx? Well, basically what we wanted was a common design environment. The previous project that I was involved at IDT, we used 3 different implementation flows. And if you stand back and think about that for a second, you can just think of what an implementation management nightmare that really is. So we said at the end of that project, that wasn't going to happen again. We were going to create something that gave us a common, singular, unified environment. As well, with IDT having sites all over the world, we have 2 design centers in Canada, 4 in the US, and 3 scattered elsewhere. It's very conceivable that any project would be multi-site, and we'd need to create an environment or a flow or a methodology that could easily deploy to these sites. The other thing we needed for Orion was something that was predictable. Orion has been on the books inside of Tundra/IDT for a number of years, and as a result, just like everyone else in the industry, we had a really tight schedule. So we wanted to make sure that whatever we came up with would give us a fair bit of predictability. Third major reason, and this is might not think is a big one, but for us was the actual ability to get access to the production validated process nodes. The design center up in Ottawa actually has very little experience at the 65 nanometer process node. And to be specific, I was the only one on the implementation team that had ever done a 65 nanometer design before. So getting access to these pre-validated process nodes and information that come with Lynx was really important to give the team a pretty good warm fuzzy as we moved forward. And finally, we wanted to create an environment that would help us maximize our risk management. Orion was basically 90% brand new code, and we knew that as we got into the very late stages of the project, we were going to have a lot of functional ECOs that were going to be fired at us. So in order to help mitigate that risk, we wanted to create something that would give us the ability to be fairly predictable and fairly repeatable once we got into those. And when we stood back and looked at it, we felt that Lynx was going to give us pretty much all of this capability. The question was just whether we were going to be able to implement it or not. So over the next couple of slides, I'll hopefully be able to show you what we were able to do. So how did we use Lynx to improve our predictability? Well, the first thing it gave us right off the bat was something we were looking for, which was consistency. Very easily made sure everyone uses the same versions of tools, libraries, common scripts, common directory structure, and just forces consistency across all the implementation team. And it's done by easily editing a text file, or you can graphically enter the information through one of these panels that comes with the runtime manager inside of Lynx. The other thing it did is it gave us repeatability. Very easily, I was able to create a fairly simple block level flow that you see right here that just consisted of a few steps that I could ensure that each block would have the same look and feel, and also guaranteed that each block was going to be done the same way. So it gave us a lot of repeatability, which helped factor in at the end to our ability to enhance our predictability. We found, though, that Lynx wasn't just able to improve our predictability. It proved to be very flexible. If I take that same simple little flow that we created, this is a hierarchical flow that basically just has the 3 steps, and we start to expand it. You can see on the right here, we get something that starts to look a lot more complex and a lot more traditional P&R type flow. It takes you all the way through from a basic floor plan, through placement, clock tree synthesis, routing optimization, even use some of the new features of ICC, of focal opt, sign-off opt, and then allowed us to incorporate formality before we could do any of the releasing. That then would allow us to release our files to STA. And we were also able to incorporate the ability to release intermediate databases, so we could do some top-level integration earlier and also validate some of our STA sign-off stuff. And then this block on the left is just a small example. If we blow up this block STA1, you can see it's a fairly simple, a much smaller subset of corners that we forced each block to at least run through some of the major corners to ensure that out of the box, each block would be fairly close from a timing point of view. As we got into the project, though, we realized that this really wasn't going to be complex enough flow. We'd have to augment it and add other things such as ECOs. What we found was very easily we were able to take that fairly simple flow and now create something somewhat more complex, not insanely complex, but definitely much more complex. And with just a few keystrokes, cut and paste and copy, we were able to take these back end sort of metal filler cell insertion, extraction steps, replicate those so that we could do the exact same, use the exact same set of scripts to implement all of our ECOs. And then this particular block ended up going through 7 different ECOs. And as we stepped through each one, it was just as simple as replicating the previous step, changing some source and destination directories, saving it, and then executing it. And it guaranteed that each ECO was always going to have that same look and feel, and didn't take very long to get it set up and done, right? So the other thing that we did is we wanted to be able to reduce and mitigate risk. And so we used sort of the management cockpit side of things, or I did, and I created a series of different sort of reports and charts that I'd used throughout the process to validate what was going on. And this is a bit of an eye chart. I know you can't see it at the back, but it's just representative of what we call a dashboard report. And what I did here is I used it to capture metrics on each of the blocks as it went through the flow. And what I wanted to do was capture things like runtime through synthesis. Runtime through synthesis when we inserted DFT. How long it took to run placement and placement optimization. How long it took to run clock tree synthesis. How long would it take to run routing and route optimization. Once I was able to do this and do it repeatedly, I was able to get a feel for exactly how long each one of these blocks, which is these vertical columns, was going to take to go through each step of the flow. So now when it came to analyzing late ECOs or late design changes, we could say, okay, I know it's going to take roughly 4 days for us to do an ECO on that large block just to get us into clock tree synthesis. Do we really need to put that ECO in that block, or can we put it in one of the smaller blocks that I can get to run in 24 hours? So it really gave us a lot of insight as to how we could manage and do things. The other type of sort of dashboard I used a lot early on in the flow was this sort of visual timing one. And what I did here is I took all of the clocks in each of the blocks and I created sort of a worst negative slack running total. And what I wanted to do is at each step through the flow, I'd snapshot what the worst negative slack was. And this is great for the small blocks because what I do is I had them set up so I could run them overnight. And I tried different scenarios and different switches inside of ICC to see what would give me my best quality results. I kick it off, let it run, I come in the morning, and in a few minutes, I could fire up one of these reports, have a quick look at it. I wouldn't have to troll through hundreds of timing reports to figure out where my timing was going off. I could just visually look and say, oh, post-route, my timing went off the rails. What happened there? And then I could go just to that step of the flow and say, okay, oh yeah, I changed these two settings in the router. And then I could actually then dive into just those specific timing reports and say, oh, okay, it affected this group of paths. That's what I need to focus on. Saved me a lot of time and gave me a lot of feeling as to how I would set things up, and also helped facilitate the porting of the flow and the setting from the small blocks to be project-wide into the large block. The last type of report I used a fair bit was this sort of trend analysis. Basically, you can run a trend analysis on almost any metric that you capture inside of the Lynx environment. And because we knew that, like I said, there's a lot of new code in Orion, and a lot of it was put in that great big block you saw on the right-hand side of the floor plan, we were really concerned, did we size that block correctly? So what we did is I basically trended throughout the early stages of the project what the number of logical instances were coming out of synthesis. And that allowed me to really see, as each successive netlist came out and they added new features, how much it was going to grow. And trust me, it grew a lot. But it gave us the ability to say, yeah, we are okay, we did size the block enough. Because if we had been wrong on what the size of that block was going to be, our only floor planning choice was basically to grow the die. And if we had to do that late in the project, forget it, it never would have happened. So it gave us a lot of insight into, yeah, our numbers were right. We were able to margin the size of that block enough. So what would I like you to take away from this short little presentation? And trust me, I've only scratched the surface of some of the stuff that we did with Lynx at IDT. Is basically Lynx allowed myself and the rest of my team to be much more productive in what they really do, which is implementing a fairly decently large and complex digital chip. From the time we installed the software, did training, did a ramp up and learning curve, and created what you saw, it was 8 months to the day that we actually taped out Orion. This ended up being 2 weeks ahead of the planned schedule, and now no, Lynx didn't give us those 2 weeks, but what it did do is because we were able to focus on what was important, we didn't have to worry about the data management stuff that happens under the hood in Lynx. We didn't have to worry about stitching together all the flows and creating tons of scripts to extract information. It allowed to act as a process enabler for us to do our job, which is just get the chip out the door. Now, it wasn't perfect. There's a couple of areas that, personally I'd like to see enhanced inside of Lynx. Number one, anytime you have a graphical interface or environment for developing flows and methodologies, what you really want to try and create is a cross between PowerPoint and Visio. So my feedback to the Lynx team would be, if you could do anything to change it, definitely do that. Build a true drag and drop, sort of easy to use environment. The other big thing is source revision control. We revision controlled all of our scripts and all of our flows. And there's a few times where I got to live with, the 4 of us working on the project that, we didn't communicate as best as we could have. It'd be really nice to have that built right into the system so you could check things out, check them back in, inside of the environment. Excuse me, what are the next steps? Ideally, what I'd like to do is just clean up some of those standardized templates for the tasks and steps before we start to roll things out, which should hopefully be to deploy it to some other sites within IDT. And finally, I know, as Moen has mentioned, Lynx does have the ability to integrate third-party tools, and we don't use just Synopsys tools at IDT, but I'd just like us to be able to do that. And there's a couple of places where we'd like to add those third-party tools in and clean that up. So thanks very much, and I'll have things over to Scott now.